to drive the webcam on my iPhone will only allow ownership to one application. So you can see my beautiful facial features in the Twitch stream when you check into it later, if you want to resource it later. So I guess we'll give it a few minutes while people log in. And start the Epic Games launcher. Okay, a couple of bits and bobs. Actually, I should wait, I think, till the group arrives. But just taking a look at where I can do makeup sessions for you guys for the GPU, sort of a second makeup session. I realized that, I'm sorry, I'm just looking at the calendar and reading the calendar at the same time as talking, so my brain is locking up a bit here. But we do have our regular 1 to 3 session that was originally scheduled this afternoon, right? So I can use that as a makeup session with you guys. We only shifted it to Thursday to accommodate Dave and, oh, I forget his name now. John, yes. To accommodate them on the Thursday, right? So we still have that 1 to 3 module that was, 1 to 3 sort of time slot that was originally scheduled with you guys, right? So we can always resurrect that. And the plan going forward, with those guys teaching you the programming side of stuff, I thought the best kind of utilization of my time with you guys is to continue just talking about Unreal Engine and sort of building your guys' knowledge up there. And I also don't mind keeping the 1 to 3 time slot open continuously, i.e. you guys will have an additional 2 hours, right, outside of the books. I don't mind that at all.
2 hour, just a quick question.
Yeah.
Just in your opinion now, if you're going to give us like sort of explanations and tutorials about Unreal Engine,
yep,
how does that bolster what John and Dave are doing?
Well, here's the thing, right? I'm trying to make connections with what those guys are doing. But at the same time, it gives you guys the opportunity of looking at another real-time engine at work to supplement what you guys did in Unity. If you guys think that that's too much of a disconnect, I don't mind. I'll talk with those guys and we'll come up with a different plan, right? I am also arranging for them to teach you guys an additional hour. I had to speak with Gordon about this, and the initial plan was that they would take over this session with you guys, but because they're coming in as a support capacity, they can't do the entire teaching, but I will be there to sort of supervise, right? The difficulty I think that I'm having with you guys at the moment is that on one hand, there's a lot of very, very kind of important things that I believe that you guys should have under your belt in terms of knowledge and experience. And I want to teach you guys that, but at the same time, I think you're just, as reflective of your question, you want something that's more directly correlates to what they're teaching, right? So, it's a matter of like, I'm trying things to sort of benefit you guys, but I'm also at your behest. If you feel like it's a waste of time, just let me know and I'll come up with something else. But at some point, you guys have to trust me, right? In terms of what I am teaching you, that's all useful stuff. Does that make sense?
Yeah, it does.
Yeah. Any disagreements about that approach?
No, I actually really like the idea of learning Unreal just because it means then that, at least that it's something, you can sit and learn theory all day, but if you're learning how to use like Unreal, you can actually use that.
Yeah. Yeah, absolutely. I do have to state outright that, the theory side of things is absolutely essential. It's not throwaway knowledge in terms of,
Oh, yeah.
yeah,
It's
Yeah.
not. Sorry, I just woke up, so I'm not.
No,
I'm
I
not
know
fully
today's
covered.
I know today's going to be a struggle with me, guys, because I was super sick over the weekend, and I was like this close to calling in sick today, but I was just like, no, I can handle just sitting here and talking my way through the lecture material. So it's going to be a little dodgy for me as well. And on top of that, it's early morning. But what I'm saying is all the stuff that I was talking to you about the ASUS color management scheme, that's really relevant to you. Things that are dealing with in terms of camera aspect ratios, device aspect ratios, that's all going to be really important to you guys later on. So I'm actually kind of hoping you guys kept notes, because once you get a triangle drawing on screen, that's fine, that's good. Once you get sort of directional lights working and reflection working, that's good. But that's all the starting point, right? There are so many different considerations that you guys have to sort of deal with. The big thing is color management. It's going to come and haunt you later on in your career. Trust me. You have to think about what is the color gamut baked into a file format. What's the color gamut that your 3D application is displaying? What is the color gamut of the monitor you're ultimately looking at, right? Because that whole side of things is massively important. So that's just one example of the stuff that I've been talking to you guys about, right? I just really hope that you guys kept notes, because it will, trust me, come back when you guys get out there and you get your first professional gig. Okay, so having said that, I don't know what your guys' experience is in terms of Unreal Engine, so I'm just going to walk you through sort of from the ground up, and we'll talk a few different things. I'm adjusting a lot of my intro to Unreal lectures so that it's more kind of lighting and shading based, but we'll just sort of take it from there and gradually just walk our way through it. Okay, so some of you guys have dabbled in Unreal Engine, I'd imagine.
I'm not a bit fiddle with it.
Yeah. Okay. So I won't walk through the setup. I'll just talk real quickly about the Unreal Engine and sort of the big three that I've had the pleasure of experiencing. So the big three being CryEngine, which is now Amazon Lumberyard, Unity, of course, and Unreal Engine. Now, one of the things I hated in the early days, especially with CryEngine and Unreal, is this idea of a lobby. I just wanted to kind of purely get into the development kit. I didn't want to deal with this garbage. Actually, let me play my screen here. I didn't want to have to deal with this kind of a thing. Just let me get in there and create my project. But it's actually quite helpful in terms of two different things. The ability to manage engine versions across various different machines. That's been super helpful. And I can roll back to any older version of Unreal if I needed to. A way of really quickly organizing my projects, which I don't really care about. But this vault idea of grabbing assets from the Unreal Engine marketplace has been a little bit of a godsend, and just a wonderful way of managing things like my plugins, different sort of assets I want to use to test out this, that, or the other thing. It's been incredibly helpful. But let's get into sort of UE4 straight off the bat.
By the way,
Yep.
I want to ask, have you heard anything back about the exam? Like, are we going to be assessed on anything like the stuff we talk in these lectures?
Yeah, so you guys know that your assignments are split up now into two, right? So the assignment brief I sent over to the guys to post on Moodle. And the exam, I had a discussion with Gordon about it, and so he's yet to write the exam, but it's definitely going to cover. It'll be weighted again more heavily to the stuff that Dave and John have covered, right? So that you guys can be
more heavily. Okay.
Yep.
So it is going to be covering stuff from the comes up in these lectures, right?
Yes. Yeah. Yeah.
Okay.
Yep. Definitely. Right. So yeah. I don't know if I can. Perhaps I can give you a specific breakdown. I suppose.
Yeah, I
Yeah.
wanted to add, if
Yeah.
we're going to have an assessment on the stuff we cover in these lectures specifically, is
Yes.
there like, yeah, like you say, a breakdown would very much help. And I'm thinking, are there going to be any extra resources like PowerPoints or anything? Or is it just what we talk in lectures going to be it?
Well, what I've been doing is streaming the lectures, right? So they're being sort of put up online, so I can give you the YouTube link for that. So that would be
Yes.
something that you can reference a little bit later. Um, in terms of a PowerPoint, I haven't been using PowerPoints with you guys in my lectures, but I can very much do that if you like and post those up as well. And it's partly my lecturing style. I'm used to with my other classes just getting hands-on and saying, look, this is how we do this and that, and sort of streaming it to the YouTube channel that the students can check back later. But I totally get when you're studying for an exam that you want to have these notes that you can refer to. So I'll make arrangements for that. This is the first class in my decade-long time teaching here where I've actually got an exam. So for the regular game students and animation students, it's all practical work, right? There's no exams. So yeah, I'll definitely make any allowances with what you guys need in terms of study material, right? Yeah, no worries. In terms of the stuff that I covered earlier, I'll probably have a chat with Gordon about that in terms of what to include in the exam. But I think if there is going to be anything from earlier talks that I gave to you that will be included, I'll make sure notes are posted up for you guys so you have something to study. Yeah. Okay. So let's get into creating a new project. Oh, for all intents and purposes, we're just going to head into the games template. You got a few different ones that are set up. The film and television one is for virtual production stuff, which I guarantee you guys will be interested in exploring. Architecture and engineering, no, that's not us. Automotive product design, that's not us. So let's open this guy up. I'm just going to start off with a blank project here, and we're just going to, you have the option to set to Blueprint or C++. C++ will allow you to open up Visual Studio. It has a direct bridge or software connection to Unreal Engine, which is quite helpful, but we'll stick with Blueprints for the time being. It's because I'm more familiar with the blueprint structure. And then I'm going to set the maximum quality, ray tracing disabled, and no starter content. So I will put this in to delete this game, and then this will be lecture 2. And we'll pop in here.
Oh, sorry, I forgot to ask. I'm going to phone my mic.
Yeah.
Do you have any idea what type of exam it is? Is it going to be like a written exam, or is it going to be a practical exam?
I'm not entirely sure, because when I had a conversation with Gordon, again, just to reiterate, this is the first class I've ever taught that has an exam at the end of it. So my assumption was that it would be a written exam. But when I was chatting with Gordon, he was saying, well, look, we're in lockdown and that kind of thing. So a written exam is sort of logistically difficult to do. So he was leaning more towards a practical / open book type exam, which I said, yeah, sure, let's do it. And that's where we left the conversation off. I guess what I'll do is, I didn't know I'd be bombarded with questions about the exam this morning, but what I'll do is I'm making a quick note here. I will see if I can get a hold of Gordon today and talk to him about it. So let's, I'll tell you what, I'll do that. So
I'll leave it with you.
Yeah. Sure. No. As many questions as you guys want. Let me make notes so that I can track it all and then get back to you guys. So,
open book?
Sorry?
Say open book.
That's a possibility, right? I don't think Gordon has made up his mind yet. But I remember when I was chatting with him, I'm just like, okay, we're all in lockdown. So how are you going to logistically execute an exam and adjudicate it? Do you know what I mean? You know, you guys are at home, you got Google there. So it's not like we can really test you, you know?
Yeah.
And I'm not a big...
Open book was the solution the last time that he had that problem, so let's hope so.
Yeah. Well, I'm not against, you know what? I'm not against it at all. You know, for me, my approach to higher education is maybe different from the other lecturers you've experienced. I'm not a firm believer in this whole idea of like, okay, you absorb as much lecture material as you can, and then we're going to test you, and you'll be left in the wind doing your thing. My goal in terms of modules is to sort of train you, and then when you get to the situation where it's like an open book test or an exam. You're actually problem solving with all the tools that you already have, like you would in a production context. You know, in a production context, you wouldn't have a visual problem that you had to solve, and you wouldn't be left alone to figure it out. And if you can't figure it out, you're fired, which is basically the kind of stress you get with an exam. I'm more of the belief that, look, here's a problem to be solved. You have all the tools that you need to solve it, right? And then just use the best of your ability and the resources around you to figure it out. So in that regard, I'm more of a fan of an open book style test anyway, because it more closely replicates how you would solve problems out there in the industry, right? So yeah, so I'm pushing for the open book, right? So ask Gordon about open exam, and then what else? So the other question about exam was the exam notes. So okay. And okay. Everyone cool with that? Any other questions or concerns? No. Okay, cool. All right. So we're going to start off. What I want to do actually is dismiss that. I want to start off with a kind of a blank slate. When you start off with sort of an open project, you get a few different things that are created for you in sort of the default world scenario. And what I want to do is walk you guys through all of these step by step, right? Because it's sort of important in terms of sort of the foundation of creating, realistic lighting in an online real-time context, right? So we'll talk a little bit through that. So today's talk will be about setting up world or ambient lighting, and then we'll talk a little bit about, we'll jump into blueprints for a real quick introduction on how to customize specific lights in your scene. Now, whenever we approach kind of rendering a scene or lighting a scene, there are a few different approaches to how we deal with CG lighting, right? One of them is after an understanding of the difference between a directional light, spotlight, omni-light, etc., is this understanding that when you're lighting a scenario, you generally start from darkness and then you slowly start building up your lighting solution. However, in the last 5 years or so, that whole philosophy, or last 10 years or so, that whole philosophy has changed in terms of introducing global illumination or image-based lighting in an early context or an early setup, so that we're lighting based on real-world conditions or real-world scenarios. You'll hear that come up quite a bit, this whole idea of replicating a real-world situation as much as possible. This is one of the things that I worry deeply about with not just you guys, but the other CG artists that I teach, is that there's a tendency to become enamored with CG, with a CG look, that you lose sight of the fact that you're trying to replicate the real world. Okay, so I'm gonna come in here and we're gonna kill these guys off, and we'll start with just a blank sort of scenario. Actually, let me leave our floor and we'll get rid of these guys, right? Okay, so first thing I'm going to do is I'm going to pop that into a folder for assets, and then we'll keep that like that. So we're going to create 5 different objects in this scenario. We're going to create an atmospheric fog, a directional light, a sphere reflection capture, a post-process volume, and a blueprint for a sky sphere, right? Now, I'll walk you through why we are creating these, because again, we're trying to replicate a real-world scenario. One of the basic things that every concept artist, visual artist, technical artist does in the beginning of approaching this black space of lighting a world is to create a sky gradient, right? And if you look way back into the horizon, you'll see that the very, if you can visualize it, the very base layer that you see is this atmospheric gradient. I'll create one and we'll talk about it. So inside Unreal Engine, we've got an area where we can create our objects. We've got our content browser and output log down here. And we've got our world outliner, which is our effective grocery list for what's happening in our scene. And then our details panel, which will allow us to kind of examine, query, and put in various different parameters for the different things that we create. So I'm going to come up here under my actors, and I'm going to look for an object that I can place into the scene. And the object that I'm looking for is the atmospheric fog. And we'll grab this and we'll drag that into the scene. Right? Now, one of the things I like to do when I drag in sort of a lot of these atmospheric, or a lot of these sort of helper props and objects, I like to set them at world 0, 0, 0. Right? So I know that because they're not transform matrix dependent, I'll just put them, where they're easily accessible. And that might raise this up a bit. So I know that it's dead center of the world. And you can see instantly what it's creating. We're just creating that horizon sort of gradient, right? Now, if I were to come in and let's see if we can bring in a few different objects here, right? So I'm going to come back into my place actors, and I'm going to take a look at placing some basic geometry, right? So let's bring in a cube, pop this in here, and then I'm going to use my scale gizmo and scale this and just make a little wall, right? Okay, so there's a few different things to talk about now that we've got the spheric far. We can talk about navigation, right? So inside the viewport, you have the ability to navigate solely with the right mouse, with solely with the mouse in your right hand, or in tandem with the keyboard and mouse. Now, because I was a PC first-person shooter guy for a long time, I'm used to the WASD and rotating with the right mouse button, right? So you can strafe with A and D, WS, and then Q and E will elevate you up and down. But you also have access to the middle mouse button, which will pan you around, right mouse button, which will rotate, and then the left mouse button, which is sort of a weird kind of dolly track thing. Takes me a while to get used to. Now, the left and the right mouse button at the same time control your elevation. Right? For your transform tools, you've got W, E, and R for move, rotate, and scale. Right? And we'll just move our guy over here. Now, we've got this atmospheric fog, but it's not really. Let's bring in another, let me bring in a sphere, right? You can see the effect that it's having. It's got this ambient sort of effect, sort of lighting everything, but we want sort of a stronger kind of directional light. What we want to do is we want to sort of mimic the sunlight. So I'm going to come over into my creation panel and we'll bring in a directional light. So I can either grab that here under the lights menu. Well, we'll just grab it here. We'll pop that in. And you can see instantly what's happening, right? So we get something that more closely approximates the direction of sunlight. Right? And down here in the details panel, we have the ability to make some fine-tuning adjustments. So we can adjust the light color, whatever you want to do there, and you can adjust the intensity, etc., etc. There are a number of different areas here that we can adjust in terms of the look of our lighting. I'm going to undo and set that back to default, and we will come back here to make some adjustments a little bit later, right? There is one thing that I was going to ask you guys. Do you guys want to follow along with this in a copy of Unreal? Are you guys set up inside of Unreal?
Download Unreal if you'd like.
Oh, well, if you haven't got it downloaded, then we'll save that for next class or next session, right? But it'd be a good idea to, one of the things that I've noticed over my time teaching is that the people who follow along generally tend to retain it better than if you're just sitting here watching me do this, right? Because to be honest, you'll watch me and listen to me going through my whole thing, and then as soon as class ends, you'll forget everything. It's generally the case anyway.
I just wanted to suggest that maybe at the end here, if possible, you could drop this project file onto somewhere where we can access it, and we can just pick up where we left off next week.
Sure. Yeah, that sounds good. All right. No problem with that. Just thinking. Yeah, no, that'll be all right. Just thinking, why don't you guys follow the YouTube video and just rebuild it? There's nothing going on in here, but that's okay. I think popping the project file will allow you to also deconstruct, right? So it's all good. So yeah, okay. So inside the directional light, one of the things I want to do is I want to separate my cube and sphere from my atmosphere, fog, and directional light. So I'm going to move these guys into their own folder, and this will be my lighting folder. And I'm going to move these guys up into the assets folder. So those guys are kind of out of the way there. And we'll pop into the directional light. And one of the things I want to turn on in the directional light is a little bit of atmospheric fog, because it's very bright and it's very harsh. And the directional light visually is somewhat disconnected from our atmosphere, right? So let's go into one of the parameters inside the details panel of the directional light and look for, I'm just going to do a search for the fog, and the directional light instance, and there we go. Atmosphere sunlight, right? So what that will do is that will apply, it will have the color that we've selected for the directional light affect our atmospheric fog background. So you can see instantly sort of the color kind of aligns, and we get a nicer looking world, right? We also get a sunspot. Now, the next thing I want to do is I want to attach that directional light to the sunspot, because right now the two are disconnected, right? So the sunspot is part of the atmospheric fog effect, and then we've got our directional light. So let's connect the two, right? Oh, sorry. Oh, actually, yeah. When we click on the atmosphere sunlight, let's let me have a quick test of this. So I'm going to rotate this guy down. Yeah, there we go. Right. So we're connected here, so we can adjust that atmosphere light. Right. Now we've got an interesting thing going on in terms of just the atmospheric sort of fog that we've added, in that we have a little bit of a mimic of nighttime and daylight, but it's not really realistic. But we'll add something to that a little bit later to sort of bring that out a little bit better. The other thing that we want to create, which we won't see an immediate effect for now, is sphere reflection capture, right? So this is something you probably want to create in all of your scenes, because what this does is it basically takes a snapshot of everything going on in your scene and maps it to the interior of a sphere. It doesn't do that, specifically, but conceptually, that's what it's doing. So you're getting this gigantic sphere that will, on all reflective surfaces, paint our skyline onto, things like metal and chrome and stuff like that.
Can I ask a question really quick?
Yes, yeah.
Do we get the publisher or the creative version of Unreal?
The creative version of Unreal. The publisher version, what that will do is when you make a certain amount of money, then you have to pay a stipend to Unreal. So that has that built in, whereas the creative one is the free community version for educational purposes only, non-commercial. Which is just an interesting side note. Unreal Engine's finance model is incredibly cool, and I don't know how they make it work, but they provide all of these tools to you free as long as you're not making a profit from it. And I think that's fair enough. And then when you... Sorry?
They probably make it work because it's funded by Epic Games.
Yeah. But for me, it's that sort of open source free software model that is really, really cool. It just allows you to be able to use whatever software you want, sort of, at your pleasure and at your leisure. And then you don't have to worry about contractual obligations for using the Unreal Engine until you start making a profit. So I think that's really cool. All right. Okay, so let's come in here. We've created a sphere reflection capture, directional light, and atmospheric fog. Now, the next thing that we'll need to do is we'll need to sort of build our solution. So what we're getting inside of the viewport is sort of a really quick kind of preview version of what our game is going to look like. But what we want to do is we want to build our reflection captures to have it sort of pre-calculate. Now you'll see that Unreal Engine will alert you if it needs to build other things. So it's saying that lighting needs to be built as well. So we'll come in here and we'll build lighting as well. And it'll go through. And what it does is it starts to calculate all your light maps. You know, yeah, well, that's pretty much what it's calculating, all of your light maps. And it's sort of processing that into your scene so we can see the final look of the lighting. It shouldn't look all that different from what we've got going on right now because it's very, very simple, right? So you can see that it's taken a little bit of the blue tint out of the lighting effect. And that's a more accurate calculation of the light the light color we gave the directional light. So if I come over here, we go to the directional light again, and we come down to the, get rid of that search term. Oh. And we come back to the light color, and we add a little bit of color to it, and then we build the lighting again. And now that light cast, you can see that when I set the initial color, there was a little bit of a change in the viewport. And then when I built the lighting, that change affected everything globally so that we see a nice color cast through everything, right? But I'm not a huge fan of that color, so we'll set it back to white, and then we'll sort of build that lighting again, and we'll go on. Okay, so the one thing that we have at the moment, whilst this is building the lighting, is that we've got very, very hard shadows, right? And this is a property of a lot of CG lights, which we kind of went over when I gave you a really brief intro into lights and shadow maps and that kind of a thing. Now, what we want to do is we want to fill in these darker areas and get some softer shadowing and get something that looks a little bit more real world, contextually speaking, right? So, one of the techniques that we would use in offline rendering for this would be a radiosity solution, a variant of global illumination, where we have sort of ambient lights being scattered into the scene from multi-directions, right? And what you would include in that calculation would be bounce light and that kind of a thing. Well, Unreal has a device or an object for that, and it is the skylight, right? So if you do a real quick search here for skylight, there it is. We'll pop that in. And you can see instantly, we get a little softer effect. We'll get sort of a bounce light hitting our objects as well. I like to set this at 0, 0, 0. And so this is sort of more closely approximating the multiple ray bounces that you would get off of a GI solution, or like I say, a radiosity engine, right? So now we're getting closer to building all of the related world lighting functions that we need to give us a baseline to feel like we're placing lights in a real world, right? Okay, so one of the things that we have, though, as part of the skylight, we come in here, might need to, let me replicate this. So I'm going to duplicate this wall object, and I hit Alt and left mouse button drag, and you can see we instantly create a copy of that. So I'm going to do that again, Alt, left mouse button drag this, and then I'm going to hit E and rotate this around. And I've got angle, snap, and translate snap turned on. The snapping functions are very, very helpful in terms of placing objects accurately. Right? And those can be set up here in the viewport controls. So you got a few different controls here. You can select manually your translates, your rotates, and your scales. But over here, we've got the ability to turn on our snapping, right? So we've got surface snapping options. We can snap to the grid. We can snap to the surface of another object, and we can set the value of the snapping. So for here, the rotational snapping, I've set to 10 degrees, and we've got scaling options set to a quarter every time we operate the scale. Up here, we also have the speed of our camera. Sometimes when I'm building, I like to slow the camera speed down, right? So I can more carefully place objects and things like that. So I'm trying to create a situation where we've got a little bit more cast shadow into our scene. Here I've just done a multi-select and use the Alt left mouse button drag again. So we'll do Alt and lift this up. Now, when you hold down Shift as well, and you drag up, so I'm holding down Alt and Shift and left mouse button. This is a super handy tool that I haven't found in any other 3D package, but it allows me to follow the object. That comes in really, really handy when you're sort of carefully placing objects in your world. So now we've got a little corner here, maybe deeper. And I'll come into this area here. Let's do a quick lighting build. Now, one of the things that we want to do is, let's say we want to come in here and we want to control how that lighting looks in that area. Right now, if we zoom out, you can see how that shadow area darkens. But then when we zoom in, everything sort of brightens up. This mimics the sort of aperture shift that happens in a camera when you go from a light to a lighter area to a darker area, and you've got an exposure shift. It also mimics how the iris responds to light information. But perhaps we might not want that, so we might want a little bit of control over that. Maybe we want to fine-tune some of the other sort of post-processed looks in terms of our lighting. So once we get that skylight in there, we have another object that we can bring in that will help us control what's going on in terms of light and shadow. And this is the post-process volume. Right? So let's come over here and bring in a post-process volume. And I'll explain to you guys what a post-process volume is and what it does. We're gonna just drag that into the scene, and we'll set that at 0. So the post-process volume is basically a compositing or digital intermediate or color grading volume. It's kind of like having, well, a post effect operate on your world, right? So if we take a look at the post-process volume, I probably want to stick this in a group under camera effects. That's probably a better, more accurate way of naming it, but I'll also include it in the lighting folder because it works in tandem with the lighting, right? So the post-process volume, you can see we have a number of different things we can control. We can control depth of field, light bloom, exposure, chromatic aberration, right? Now, a lot of this, what do you set this stuff as? A lot of these sort of different features, chromatic aberration, camera, lens flare, right? You can go through and you can make up a lot of this stuff. But this is why, again, it's really sort of important to understand how real-world cameras are affecting the stuff that we're building in a real-time context, right? So typically what I would do is I would do what's called data wrangling, or I'd get data from a specific camera. And even if it's a complete fictional game world, you will oftentimes find that sort of layout artists and technical directors will very much design the cinematography, the digital cinematography, based around real-world cameras. But we won't concern ourselves with that today. I'm just going to go through some of the basics. What I want to do is head over to my post-process volume in terms of exposure, and I want to set that exposure min and max brightness. Now, with the min and max brightness, if we set a value of 1, that effectively locks it, right? So with that set, I'm going to come through and we're going to build lighting again. And what that will do is, again, make sure that we don't have an exposure shift from that range of what's minimum bright to what's maximum bright. It'll just stay locked, right? So if I'm this far away, it'll have the same sort of lighting conditions as being this far away. Now, why we would do that is, why do we? there seems to be a little bit of an exposure shift going on. So min, max, those exposure values are locked. Okay, let me just double check my directional light here. No light shaft, no light shaft bloom. And we built our lighting. Okay, I'm going to pop back into post-process volume and let's turn these guys off. Oh, I know why. Okay, so I'm going to turn on the min brightness and max brightness. The reason why the post-process volume is not showing us our effect is because we are outside the bounding box. Right? So that's the one thing about the post-process volume, which is really, really cool, is that you can apply the post-process volume to specific areas in terms of, let's say you wanted one area to have kind of a crazy bloom effect, but another area something else, like a depth of field sort of thing, right? So what I want to do is I want to set this so that it's affecting our entire world, right? So inside the post-process volume, I'm looking for the infinite extents or unbound attribute just by typing infinite under the post-process volume. There it is. I'm going to turn it on, and that's what I wanted to kind of set up. Right? So now we've got no exposure shift as we move around. You know, sometimes it's a good idea to also, you know, expand out the post-process volume because it can get quite confusing, you know, if you leave it at a very small size. So there we go. Now this makes for a better starting point in terms of lighting because we can more accurately gauge how our light is affecting certain objects as opposed to exposure shift kind of getting in the way and muddying your lighting solution so you don't exactly know what's going on. Inside the viewport, we have the view of our game as we're building it, but we also have our helper icons that are available as well. Sometimes they can get in the way. So if you want to take a look at previewing your game, what it might look like, you can hit the G hotkey. That gets rid of your game icons. So then you have a sort of a clearer kind of better view of what you're trying to put together, right? So I'm going to bring those game icons back. Now, this is very, very different from launching an instance of your game. So in here, we've got the ability to play. You can just hit the play button, but you can be more specific. You can do a mobile preview. You can preview this in a new editor window, and I'll show you those two, right? So when I hit play, this is the experience that my game audience will have, right? And then you hit escape to come out of that. The other more often one that I use is play PIE. So play in editor window. And what this does is it creates a new editor window. This is handy when you have a dual monitor set situation, right? So I can drag this over to like my TV monitor or broadcast monitor. Oftentimes at a game studio, we'll have our development monitor and we'll have our broadcast monitor. We always test our broadcast monitor to make sure we're doing accurate color and all that kind of stuff. So more commonly, I'll use this PIE window to more accurately gauge what's going on or what the consumer will see, right? And then you can hit escape to come out of that again. Any questions so far? Very basic stuff. Very, very basic stuff. Okay, so yeah. Yeah.
So with the post-processing,
yeah.
Can you assign it to a certain area, or is it for the entire scene?
What I did with the infinite extent unbound is said, look, this is for the entire scene, right? But when I click it off, right, looks like there's no change that has happened. But watch what happens when I scale down the bounding volume, right? It seems to have lessened the effect, but no, really what has happened is we're outside the volume. Notice that when I go in the volume, there was a little click shift in lighting, right? So when I enter the volume, boom, see that? So in that regard, that's how you control and assign the post-process volume to certain areas. So I can just as easily bring in another one, right? And then put that somewhere else, right? So where did you go? Post-process volume. Where did you? There it is, right? So this, I can do other things with this post-process volume, right? So I can come in here and let's scale it up maybe. Oh, with most of these sort of, I guess, physics-based volumes, there is a rule of thumb. You want to keep them as cubic as possible because of the voxels that divide up. And do you guys know what voxels are, right? No? Yeah.
Remind us.
Oh yeah, okay. So a voxel is a volume pixel. Basically, it's like you guys know what pixels are. So a volume pixel is a pixel in 3D space, right? So every cube is divided up into these voxels, right? Now, as with when you're looking at a photograph on a monitor that's shot with square pixels, as the minute you make those pixels rectangular, you've stretched that image, right? You're not getting an accurate image. Same thing with voxels, right? So if you have rectangular voxels, you're not going to get an accurate simulation. You're not going to get an accurate post-process look, right? So a rule of thumb is to try to keep them as square as possible, as cubic as possible, right? Now I can come into this post-process volume and I can change, let's do, what would be, let's turn on bloom intensity, right? So I've got a bloom intensity inside this volume, but when I exit, that bloom is gone. I can enter, the bloom happens, and then I exit and I'm into the other volume, right? So you kind of get the idea. Obviously there's a computational cost, and I like breaking things. I've yet to break the post-process calculation cost, but I plan on doing it someday. I wonder how many post-process volumes I can place in a level. But for the time being, most people just place one universal post-process volume for the entire level if it's an exterior map. So if you're going from an exterior to an interior, obviously you probably want a different post-process volume the minute you enter that derelict sci-fi base, right? So, you know, it's that kind of a thing. And it's wonderfully versatile, which is what I love about it. Right? So I'm going to come back here and we'll look for the infinite extents, and I'll turn that back on. So now that post-process volume, again, is affecting the entire world, right? So that's how that works. Okay, so now I want to get a little bit more specific about what we're creating in this atmosphere, right? I mean, it's nice we got a sky gradient and things like that, but let's bring in clouds and all kinds of other stuff. Well, Unreal comes bundled with something that conveniently provides a great starting point, and that is the Blueprint Sky Sphere, right? So you can see I've got it here, and again, I'm just going to drag and drop this in, and we'll place this again at world 000, and then I'll raise it up. So I like to keep, like I say, all my sky elements sort of lined up so I know where they are and I can get at them super quick. Right. So what does the BP Sky Sphere have? Well, it's got a static mesh sky. It's got sky material, cloud, texture. The sun disk is based on the rotation of the directional light, but it's a bit tricky to set it up, and I'll show you why. We have the ability to change the cloud speed, the cloud opacity, etc., etc. Right. So let's pop down into the Sky Sphere, and the first thing I want to do is link it to our directional light. So here, let's see if we can just do a search for it. So there's a directional light actor, and I'm going to choose the one that I have in my scene. And so now you can see it pops to where I originally placed my directional light, and we can see the clouds appear a little bit more because it's adjusting to the time of day, etc. So you got a little bit of time of day functionality built into this as well, right? So that makes it really handy. I'm going to move this sky up into my lighting folder, and what I might do is put an exclamation mark in front of lighting, which will move it right to the top. I like to keep my world lighting right at the top of my world outliner because it's one of the first things that you set up and you adjust, right? Okay, so yeah, this bit's a bit tricky. So repositioning of the directional light. So say you're not happy with where you've got the sun disk, what you need to do is you need to deactivate the blueprint sky sphere. And then you have to go down to your directional light and then reposition that guy. Let's bring him back down, actually, down here. Reposition him. And then you need to re-engage the sky sphere. But notice when you do, it pops the directional light back to the original position. Well, what you need to do after that is you need to refresh the material for that sky sphere. So that would, let's see if we can. So there we go. So I click on refresh, and then the material pops back into place. Now, the reason I wanted to show you this is to show you the difference now between just creating live objects in your world outliner and using blueprints, right? Blueprints, because there are a series of different dependencies that are attached inside of a blueprint, and I'll show you that when we create our flickering light, it's one of those things that needs to be recalculated or executed at runtime to see the effect, right? So right now we've been working with a lot of real-time feedback in the viewport, building inside our world outliner, but it's very, very limited, right? So we've had to build certain objects to see their final state inside the viewport. The blueprint, not only do you have to build all of your elements in your scene, but to accurately gauge what the blueprint is doing, you have to refresh whatever it is you have in the blueprint, or you need to run the game, right? So when you run the game, that's when you see the blueprint in action, because it's executing at runtime, and you'll see that a little bit later on. Right? So I think that's it. Should we create the light shafts? Yeah, okay. So I'm going to go into the directional light, and we're going to turn on a few different things. Let me pop back in here, and we'll move this guy off to the side. What I'm going to do is I'm just going to add a little bit of flavor to that sunlight. We're going to go into the directional light, and we will look for our, should be down towards the bottom. Oh, there we go. We've got light shaft occlusion and light shaft blooming. Now I'm hoping that, yeah, okay, it is working. That's cool. So now we've got a little bit more of the volumetric lighting effect that I love. Every artist loves turning this on and making adjustments to it because it's your God rays, right? But it's really, really intense. So we'll make some adjustments to this in terms of, well, first, let's go back to our blueprint control and play with our sun's brightness to start off with, because it's super, super bright. So I'm popping back into the blueprint and heading down to, let's see, sun height, sun brightness, right? So let's bring that brightness down a little bit. Now refresh that. Directional light, sun brightness, blueprint, sky sphere. Okay, it might be masked by the bloom scale. Oh no, it's working. I can see a little bit more of the outline of the sun in there. I'm gonna actually come down and change the bloom scale just so we've got a little bit more to work with. So with the bloom scale over here, I'm gonna bring that down just a bit. Oh, it's really responsive. So let's go 0.01, right? Something like that. And then we can go back into the blueprint sky sphere and adjust the brightness of it here, which will hopefully, there we go, right? So we can see a little bit more of the effect. So what I'm doing is I'm working with the two in tandem, right? So I'm going into the blueprint sky sphere to adjust the brightness of the overall effect in the sky, and I'm going to the directional light to control sort of the blooming intensity. Right? And then you can go and sort of fine tune that and tweak that. Unfortunately, I was hoping I would get a nice shaft of light through there, but let's try and close up that gap and see if we get it. I'm going to come in here and I'm going to build the lighting again. And hopefully we'll get a shaft of light. But obviously this works really good with a canopy of trees. And that's something that'll be sort of a fun kind of look to play with. We'll leave it at that. But you can come into your directional light and tweak and play with the settings until you get some nice kind of shafts of light, which is really quite cool, because if I were to build this traditionally inside of Maya, there would be 5 or 6 different steps to get light shafts and volumetric lighting effects working. It's wonderful that Unreal Engine provides this sort of built-in, already set up and ready to go. Okay, so light shaft blooming, bloom scale, bloom threshold. Let's increase that threshold. It's going to take a little bit of fiddling to get that to look right. Okay, so those are your basics in terms of setting up your world light. There's not much more to it than that. So we got our atmospheric fog. We have our directional light to give us that primary sunlight. We've got the skylight. Put that in the lighting folder, right? And the skylight enhances the directional light by giving us the global illumination, multi-bounces, the bounce light in the scene. Then we've got the sphere reflection capture, which if we bring in reflective objects, will capture the world environment in terms of all of the reflections. And then we've got the blueprint sky sphere, which gives us a functional sky. Now, the wonderful thing about the Unreal Engine Marketplace, a good example here of how beneficial it is, there are a number of freelance artists who've created their own BP sky spheres for multiple different looks, right? So you can always go through. Some of them are provided for free. Some of the more costly ones, I say costly, I think they're like 10 quid, 20 quid, but some of the sky sphere effects are just amazing. And what they've done is they've just gone in and grabbed all the cloud textures that you would want and done all the alpha work and everything and assembled the whole thing for you, right? Okay. Any questions about that? That's just sort of a basic setup. No? Okay. So I'm going to come back here and super quick, just come back into my basic objects and we'll bring a cone in, right? So now we're going to dive into some of the basics of the blueprint editor. And what I want to do is I'm going to come in here first. Let's do something like that. I'm going to put a little torch in the corner here. I'm gonna rename that torch. And what we're going to do is we're going to throw an Omnilight in there, and we're just going to have it flicker. So this will be kind of an introduction to the basic sort of structure of a blueprint and how it works, right? So basically, the blueprint is kind of a visual representation of a C++ class, right? And how we create that is we come over into the blueprints menu, right? And we can create an empty blueprint class. Now, the beauty of the blueprint class is that you can actually send it to Visual Studios and you can take a look at the code base for it. It's very, very versatile. And the blueprint editor and Visual Studio remain bridged. So when you make changes in Visual Studio, they'll update in the blueprint and vice versa, right? It's really super handy. Okay, so, well, for you guys, maybe not necessarily for me. Okay, so basically, Unreal Engine provides a series of classes for you where you can create objects, assets, and things inside the scene. Now, there's a hierarchy of functionality built into a lot of the blueprints, right? So if we take a look, the actor is a very, very basic object that can be spawned at runtime, right? And the pawn kind of extends that actor class because it can be possessed, right? So you see here, it can be possessed, it can receive input from a controller. So that's the essential difference between the two. Character, player, controller, they all kind of build on that. But the two basic classes you end up working with all the time are the actor class and the pawn class, right? So I'm going to come in here, I'm going to create an actor class. I'm going to create that in my content folder, and it's right away saying, do you want me to create a blueprint folder for you? Well, yeah, absolutely. And I'm going to name this BP and call it Flicker. And I'll create that in there. I'm debating whether or not to use the movie set. Okay, so straight away, we open up into another editor. Now, with the Blueprint editor, you can kind of think of this as a mini Unreal Engine, right? It's got its own details panel. It's got its own components over here, which is very, very similar to the place actors. So I can add components and all kinds of stuff in here. This is probably the only addition to the editor that extends its functionality, and it's this ability to create specific events or create specific functions. There's a library of built-in functions that you can draw upon. You can create individual macros, etc., etc. So this is where we build and extend the functionality of any object that we create inside of Unreal. Again, you can see in the details panel, there are a number of different sort of variables and attributes that we can adjust over here, right? Okay, so what else? Yeah, quick anatomy. So inside the viewport is where we can sort of build our objects. And we got the same viewport controls that you would normally have in the editor. But here we have a construction script, which we won't be dealing with today. That allows us to custom create various things at runtime. And then we have the event graph. Now the event graph is where we're going to kind of build that sort of functionality into our light. And I'll talk about the different bits and pieces of the event graph in just a moment, right? So the first thing we're going to do is we're going to bring in our asset that we created in here, our torch, right? So let's pull this in. Oh, actually, I think what I need to do is I need to create this as an asset first. So I'll walk you through that, actually. So with the basic object that I created, right? I've pulled it in from the creation menu here, and it's created an instance of that object in the world outliner. But what I probably want to do is to turn that into an asset that I can use over and over again, right? Let's say we want to build multiple torches inside of our sort of castle block out here. So what I'm going to do is I'm going to right click on this torch, and I am going to convert it oh, there we go. So I'm going to convert this torch to what's called a static mesh, right? So what this will do is it'll say, okay, I'll create a mesh for you based on this object, which is only live in the world right now. But with that static mesh, you can reuse it again and again in various different levels. So it's going to create a folder for me called meshes. And I'm going to put in here my, I'm going to call it base torch, right? So it's going to create that folder for me and pop that in there. Right? So let's go back to our blueprint. I'm going to tear this menu off again. Pop back to my untitled project. So again, we're back inside the blueprint editor, and I'm going to drag and drop the base torch in there. And there's another interesting behavior to notice here is that the transforms that I gave it whilst it was existing in the world have been reset, right? Because that transform matrix only exists for this instance of the torch in this sort of level world outliner, right? So if I want to make kind of permanent changes to this, I can do them here inside, or not permanent, but changes that will propagate through various different levels. I can do that here, right? So I can do exactly what I did before, rotate this guy 180, and scale this up, etc. Right? So if I want that to be my base torch shape, I can set that in here inside the blueprint. Right? Now, keep in mind that that change only exists in the blueprint. My base object still looks like this, right? So I'll talk a little bit about the difference of your object state inside the blueprint editor, inside the world, and inside the inside here in our content browser by double clicking on the one in the content browser. Now, when you double click the one on the content browser, we have another editor window. This is our mesh editor window. This allows us to investigate geometry in terms of what materials we want to put on it, How do we want to re-import the base mesh? Do we want to build some collisions on it? Anything to do with mesh actors you can do inside the mesh editor. But that's outside of what I wanted to talk about today. But it does show you that there are a variety of different editors that you can access simply by double-clicking assets in your content browser. There's also an animation editor. There's a few other editors that you can access from within Unreal, right? Okay, so we've brought in our torch asset. And let's see. Okay, yeah, so I'm going to come in and create a point light object as well. So what we're basically doing inside the viewport is building up what our final asset would look like. Now this, obviously, you can use placeholder torch geometry if you want something a little bit more fancy, but just for the sake of going through this super quick, it's just a cone. And I'm gonna come over here and we're gonna look for a point light. There you go. And I'm gonna bring that point light in, right? And I'm gonna scale it down a little bit in terms of the size of it. Ooh, it's gonna take forever. Let's set it to 1, 1, and 1. Static, stationary. Let's compile that. Oh, why are we not? Okay, so what am I forgetting here? Why is it adjusting to the size? Are we inheriting the transforms? Let's move this to flat hierarchy. I wanted to move this to a flat hierarchy anyway, but it doesn't seem to be responding to the scaling. Okay, so what I'm going to do is I'm going to reset these guys back to 1. And let's take a look. A little bit lower down, see if there's a bounding box setting for this. I don't think there is. Huh, okay. But we have access to the other transforms in here, I believe. And rotate. Okay. So we can rotate and translate it. It just seems not to be responding to the scaling. So that's interesting. Yep, not responding to the scaling. Now, I'm just going to soldier forth and build this so that you can see what it's like contextually, and then we'll see if we can problem solve that a little bit later. Now, this just means we're going to have a point light effect. If it operates the way I think it will, it just means the bounding of the point light will be huge, but let's see if we can, again, adjust that a little bit later. Okay, so I've got that in there, and what that effectively has done is it has allowed me to access these objects later on when I move over into the event graph, because they're part of this. I guess it's like a mini level, right? So I'm going to save, and again, because the blueprint is kind of like a visual scripting version, a visual version of C++, you have to compile this to see any of the changes that you have kind of appear instantaneously. So that's cool, and we've saved it. So this saves it in the content browser, and then we can flip over and talk a little bit about the event graph, right? So what we want to do is we want to create that. We've got that Omni light, but what we want it to do is we want it to flicker, right? So we have to understand the behavior of a flicker. So there's got to be an off moment and a certain delay for that off moment, then an on moment, a certain delay for that on moment, and then that has to be random. So that's basically what we're doing. And it's fairly simple. Now, inside the event graph, what events are are things that will execute once the game begins running. So you get some very, very basic events to work with. We got event begin play, which is basically a flag to say, look, as soon as the play button hits, start this, right? We have actor begin overlap. So this is really basically a collision thing. So it's like when the game launches, the certain nodes that are attached to this will have a collision relationship. So if they overlap, something will happen, right? Then we have an event tick. This one's very useful for animators. It's saying that once the game begins playing, at every tick or every frame, if you're running the game at 60 frames a second, every frame have something happen, right? So that's basically what these events are, right? If any of you guys have done any sort of web design stuff, you've dealt with events before, like event mouse over and things like that, or event scroll wheel, right? It's sort of similar in concept, right? So we're going to start building up our event begin play, right? Oh, yeah, I wanted to show you guys the documentation, right? So a good place to start in terms of understanding sort of blueprint functionality is to take a look at what's available in terms of events. This is really interesting for me because I've only ever used half a dozen events, but there's quite a few things here that you can set up or sort of, I guess, pre-set up before the game launches and starts to play, right? So we've got our actor end overlap and definitions of those. And the basic thing that we're doing here is we're building something like this, which says the minute we have this event fire, we'll branch off based on a condition, et cetera, et cetera. The result will be fed into the next function, and that function will execute. It's that simple. Right? Okay. So we're going to bring in our first node, and here, inside the Blueprint script editor, you have the standard tools that you guys are used to, like tab typing and IntelliSense, right? So when I come in here, I just hit the tab button and start typing delay, right? And you can see that there's a built-in function already for delay, right? So we can bring that in, and then we'll hook up our event begin play to that delay, right? So this will be our sort of off moment, right? So the next thing I want to connect to this delay will be a duration. Now, how you connect this up is you can grab the duration sort of gateway here, and you can pull out a wire. And with that wire, the minute you let go of the left mouse button, it'll ask you, what are you after, right? So we want some sort of random number generator, right? We want to randomly generate a float, and we're going to give it a range, right? So we're going to pop into here, and we'll say for the range of that light, for the off moment, we'll make it 0, 0.2, like really small, right? So that will be our duration. And we want to create a reference to our point light to say, okay, that delay is going to apply itself to our point light. So I'm going to grab the point light here, and I'm going to left mouse button drag it in here. This creates a reference to the point light that we're building inside our blueprint editor, right? And then what do we want to do to this point light after the delay has completed its calculation? Well, we want it to set the intensity, right? So I've just dragged out another wire, and we're going to look for set intensity, right? And so we've got that target for our point light. And what we want to do is we also want to, after that 0.2 or 0 to 0.2 delay, it's going to set an intensity, but we also want that intensity to be random as well, right? So I'm going to actually take this and copy paste it because it's going to be the same function I drag in, and I'm going to pop this return value into the new intensity. But we'll change our min and max, right? Something like, we'll go real high, 900 to like 3,000, like really bright, just to see a result. Okay, so once the delay has completed, we'll go into the set intensity of the point light and its new value in terms of its intensity. And then what do we want it to do? We want the end result to it'll set the intensity, it'll shine for that moment, and then it'll go back and calculate another delay, right? So the end result comes looping around and joins up with that calculation. Now we've created an endless loop, right? So I'm going to sort of rearrange this a little bit better, right? So we've got the event begin play, we've got the delay, we've got the point light, and then we've got this, right? And then we can always come in here and click on our point light, and, or actually, let's grab it in here. And I'm just gonna change the light color so we have something that we can kind of gauge against and see if the effect is working. And then all we need to do now is compile and then save, right? Now, it's not going to kind of instantly appear, right? What we want to do is we want to take our original torch. I'll hide it for the time being because we're not using the geometry from the torch we pulled in here. We're not using this geometry. We have actually put it all together inside the blueprint. Now, the blueprint here is what we can drag and drop in here, right? And we can sort of rescale it, you know, to get it to perhaps the size we want it, right? Now you can see it's not really working. I'm going to save content for a sec here. So I'm going to save this. I'm going to create a new folder for maps. So to see this in action, we just have to hit play. And there we go. We've got our flicker effect. So there's a few things that we talked about today. One was just sort of to give you a very, very basic introduction to blueprint scripting. One of the things we'll probably do sort of next class is extend that a little bit by going into camera systems and how to set up the cameras using blueprints. We'll talk about a number of different post-process effects and things like that. But at a very, very basic level, this will show you sort of how you can create these more complex sort of effects and objects inside Unreal Engine. Now, I've skipped over a lot of what I would do with my normal sort of animators and game designers, and that is to go over object types, building a scene, and all that kind of stuff. But I think it's more interesting for you guys at this point to kind of understand how the lighting relationships work between the various different assets that you can bring in, and how a very basic blueprint works in terms of adding sort of a little bit of functionality to the lights that you are creating. Okay, any questions about that? Oh, I haven't been checking the chat. I don't know if you guys have been posting anything in the chat. I'll just pop over there super quick. Yeah.
I haven't got any questions.
Yep. Okay. Okay, that's cool. And we are at 11:13. Okay. Let's take a quick break. I'm going to run down and grab a cup of coffee, and we'll come back, and I'll continue introducing you guys to Unreal. Okay, so I will see you guys in 5 minutes. Computer okay, or is it so frustrating? Yeah. Okay. Okay, guys. I'm back. All right. So, hey. Okay, so I think I was debating whether or not to kind of continue on with material editor stuff. But have you guys been in the process of downloading Unreal while I've been talking to you? I know that a couple of you have.
Yeah, I've been downloading it. It's quite big though, so it's taking its.
Yeah, it's taking its time. Yeah,
Plus,
do you?
plus you have to download it through Epic Games launcher.
Yes.
That launcher like tanks my download speed, so I'm being completely real. I'm not going to be ready by the time this lecture's even close.
Yeah, okay. That's cool. That's all right. That's totally cool. So the idea was for me to lecture you guys and have you sort of build along, give you guys some time to build along with it. But I'll tell you what, we'll try and jump into material editor stuff. Yeah, why not? We'll jump into that. But before we get into that, I'm going to talk to you about today's lecture and what you can do to sort of try this out on your own. Now, it's really boring to kind of do this with just static cube objects. I did that to try to simplify the lecture and get to the heart of the concepts, but you guys ideally would probably want to be using stuff that looks a little bit nicer to do your tests and things like that. So one of the things that is quite handy to set up is the Megascans plugin, which I think I talked to some of you guys about. I'm not entirely sure if I've told you guys all about it. But what Megascans is a suite of tools that are available for free from a company called Quixel. Right? So I'll just open up Quixel's Bridge. It's something that I recommend you guys download and install, and you'll see why in just a second. So they must be installing an update. There's also another tool that's available from Quixel called Quixel's Mixer, but you guys might not be as interested in that. Quixel's Mixer is just a utility that will allow you to create complex materials, but it's more geared towards the junior texture artists. It's a very simplified version of Substance Designer, but it might be good for quick tests and things like that. Okay, so Quixel Bridge is a utility that also connects to Quixel's online library. And what this library provides you with is just a series of surfaces and a series of assets that you can pull into your Unreal Engine project and use straight away. And all of this stuff is free. Now, what the Megascans are high resolution, 8K, sometimes 16K scans of real world areas, right? So they have scans of like rocks and boulders and all kinds of stuff. So if I were to take Mossy Stone Wall, right, what this Quixel Bridge will allow you to do is to select the asset library at whatever resolution you want. And generally I stick to 2K resolution when I'm like quick prototyping and building stuff. And it will allow you to download that to a library area that you set up when you first install this software. So it'll ask you, when you're installing the software, where do you want to put all your assets and materials that you download from Quixel, right? So here, I believe I've just given it one of my media drives. I generally tend to create a global folder, right? And I'll create a libcg folder, and here I'll put my assets and scans, or assets and 3D models and assets and shaders and things like that. So I recommend you guys organize yourselves that way. Create a library area of global assets or global things that you might want to reuse and things like that going forward, right? So it'll automatically download into the Megascans folder for me, and it'll create this folder structure for me, right? So that's quite handy. But getting it to Unreal is a two-stage process. So the first thing I'll do, let's grab that Mossy Stone Wall. I'll download it. It should be quick. It's not a huge asset, but yeah, it'll be lightning quick. Once it downloads, it'll give you this option to export. Well, where does it export? Well, when I click on the export settings gear icon here, we've got download settings and export settings. I'm going to click the export settings, and I'm going to say, look, for my export, I want you to send it to Unreal Engine, right? And then it'll say, okay, I can do engine version 4.26. You can select whichever engine version you want. Where's the where's the plugin located, right? So when you install on Quixel Bridge, it will also install the Unreal Engine plugin for you, and you can direct it to where that Unreal Engine plugin is. But this is what I'm concerned with here is the default project. You basically just select whichever project you want that asset to install to. So in this case, let's pop over into, just got to remember where I set my project. One of my game design students told me this before in terms of where to find my projects. Oh, I think it's in here. So it's oh, I know. I'm gonna come over to content folder, come over to my meshes, and I'm gonna right click in here and show in folder view. Show in, actually, let's see if we can, there we go, show in Explorer. All right, so I'm in project D, delete this game, lecture 2, there we go. All right, so I'm gonna come over into my Quixel Bridge, and we'll just navigate to that project. So that is my D. And then delete this. Okay, so that's my export target set up. I'm going to go back, and then we're going to hit export. It says exported successfully. So if we come back into Unreal, you can see it's automatically detected the change, and it's imported that asset for me. It says no smoothing group information was found. That's okay. And you can see that in the content folder, Megascans has created a Megascans folder for us. And in here, we've got the 3D assets. So that's Mossy Stone Wall, right? So you get a bunch of different stuff here. What you get is the actual CG asset. You get the shader that was built and the various texture maps that go with it. So we've got an albedo map. We got, which one's this one? DXT1. This one is the... Okay, so I'm going to assume this is the ambient occlusion map, and this is a displacement map. So we can examine the asset by double-clicking on it, and it opens up our geometry editor. And we can take a look at the quality of that asset, right? As well as define certain things like which LOD level we want to use, whether it's a low-resolution geometry or a high-res geometry, et cetera, et cetera. And then placing this, we just simply drag and drop it in, and we've got that in our world. Now, you can see that it's not being affected by the lighting. Well, because once we do that, we also have to come in here and we have to build lighting, right? And then it will be influenced by all the different sort of lighting assets that we've built at the top of this lecture. There it goes. And has wrapping UVs. Okay, well, that's a whole other issue. Okay, so it's adjusted for the lights we have in the scene, et cetera, et cetera. So we can we can bring in whatever props that we want for quick prototyping. I know I've talked to a couple of you guys about this before. There's a lot of assets that are out there available for you to use for testing purposes. It's a lot better to try to get a lot of your tests happening with objects that you can put in situ. Right? So if you want to test for a sci-fi, or if you want to test reflectivity, why not create a fancy sci-fi sort of exterior? It only takes you, maybe an hour to set up your scene based on a lot of free assets that are floating around. And then you get a little bit more of, not more of an accurate result, but it's just a little bit easier to gauge when you're looking at creating an effect in a particular environment, right? If you want to isolate an effect, I'll give you the opposite advice. If you want to isolate something, or if you're doing a lot of problem solving, then it might be a good idea to just do it in sort of a white box scenario. So you get the purest, sort of the most clinical sort of response to whatever it is you're testing, like a flickering light or something like that. Right? So you hit the play button, right? That's not close enough to be affected. Let's try and bring this guy in a little bit. And again, we'll build the lighting. And should be quick. There we go. That's cool. Haha, okay. Doesn't look like it's affecting our object at the moment. So I probably want to go back and investigate that. I'd imagine it's in the point light itself in terms of what it's lighting up, right? So you can turn on things within the light in terms of whether or not it's visible in the render or hidden in game, and as well as whether or not it affects objects or not. Let's see. Attenuation, cast shadows.
Hold on, so we're checking if the point light is lighting up the multi-wall, right?
Yes, yeah.
Yeah, could it not be because the cone there is blocking its light source?
Oh, it's possible. Yeah. I don't think it was occluding. But I should be. Yeah. Yeah, let me actually, I've moved this closer. I want to take a look to see if there's a localized effect along the top of there. But yeah, I see what you're saying. I don't think I've put the Omnilight inside the cone. So rebuild that lighting. Yeah, the geometry is not accepting lighting at the moment. Huh, okay, well, that's the wonderful joy of bug hunting. No matter how perfect a level you build, there's always something that you have to go and investigate. My first suspicion is either that the geometry is not accepting light value, or the light has been set up so it's not intended to light objects in the scene. But I suspect it's probably the stone wall because the light is working on the basic static meshes that I brought in. So for all intents and purposes, it should be hitting our object. But yeah, so I'll probably try to investigate that later. Okay, so that's that object. There was something else I was going to talk about in terms of what else was I? Okay, well, let's see how this material is constituted. Right? So I'm going to double click on the material, right? And we get this sort of material editor, right? And what this allows us to do is to see the effect of our texture maps all kind of melded together with a material shader on a very simple object, in this case a sphere, right? So we can look at the details of how the texture maps are layered in. Now you can see I've got a fuzz map, a roughness map. Ah, yeah, okay, so that's a roughness map, not an AO map, and then an albedo map. And you can see areas that we have available to plug in various different maps, right? So you can always go back to the Quixel Bridge and you can download a variety of other maps that are available. Now, if I come into my download settings, you can see that I have a variety of different maps that I can turn on and bring in to the solution, right? The default usually indicates that there are no other maps available other than the ones highlighted here. But I always, for the sake of curiosity, turn a few things on I might need, because you never know. And so I should have gotten opacity map, an AO map. The fuzz map came through. There's a few maps that didn't make it through. So I'd want to kind of investigate why those didn't download properly. But what ends up happening is that you can get additional maps. You can come into the material editor, and it's simply a drag and drop functionality. So when I go in my content browser, I can say take my albedo map and maybe actually let's pop this in. We can drag and drop the same map into, say, like into here. It should accept. Okay, so now I've just reused one of the maps, and that's driving my metalness channel, right? And we can do the same thing for, well, let's, yeah, no, that's probably, we've only got normal maps, right? So, but with the list of the texture maps you have available, you can sort of add and extend the material functionality, right? So I'm actually going to pop into my Albedo map and look at the texture editor. So this is another editor that you have available, right? So you can open up individual textures as well, and you can change things like their brightness, et cetera, et cetera. Oh, it's just not working for me today. Holy cow. Like, you can adjust the brightness and then, yeah, nothing happens. All right. There we go. Right, and you can save that, and then you'll see those changes reflected in the Mossy Stone editor and that kind of a thing, right? So that's your basic material setup and your material properties. So let's go in and build a really, really quick material of our own to sort of add to this. It's not going to be anything amazing. It's just going to be very basic, but just to show you guys. So I'll probably create it inside here, and I'll create a new folder. Let's call it alternate. So an alternate material. I'm going to come in here and double click that. So I'm going to right click in the content browser. And you can see that when you right click in the content browser, you can create a few things straight away. Now you can do that same functionality under add and import. And you can also go up into these place actors and you can scroll through these menus. Same kind of a thing. But we're going to right click in here and we're going to create a material, right? And we're going to call this material basic, something like that, right? So when I double click on this guy, we'll get a slightly different material editor because we're building this material editor up from scratch. Now, it looks familiar, right? It's very, very similar in structure to the Blueprint editor. You know, we've got our material preview window in here, and we've got our base material here, and then we've got a palette of different functions that we can pull in from here, right? Here we can add a variety. Here's our details panel where we can add a variety of customizations to this material, but we're going to ignore this for the time being because we're going to be building our material inside of here, right? So the first thing to note is that the material definition can be changed over here. So we can create a surface material, which is what I'm going to talk about today. We can create deferred decals. Light functions can operate as a material. You can create a post-process material as well. You can create quite a few different material functions inside here. As well, if I turn on translucent in terms of the blend mode, this will also open up opacity as an option of something we can play with. So if we wanted to use some kind of an alpha effect, we can turn that on in here. You notice that once I change that functionality, other functionality grays out, right? So when it comes to creating a material, you'll have to create multi-materials and combine them to create certain effects and things like that. But we'll start off with a basic material for the time being. So I'm just debating what to show you, but I think I'll just go super basic for now because we'll take a look at layered materials, which is one of my favorite, a little bit later on. Okay, so let's say we were kind of roughly sort of rebuilding this from scratch, right? One of the things I might want to do is take my new Albedo texture and create a new base color. It's very simple. We just grab this guy, bump, pop it in, right? When we drag and drop, we get what's called the texture sample node. You can also get that by right click or tab typing rather. You can bring in a 2D, should be a 2D texture sample parameter 2D, right? So you can bring that node in. It's the exact same thing, right? And let's just do something simple. So I've got two texture samples in here. I've got the regular Albedo map and I've got the black and white map. And what I'm going to do is I'm just going to multiply these two guys together, right? So I can tab type and bring up my multiply, And you can see you got access to a variety of different math nodes. I'm going to take the RGBA and the RGBA here. I'm just going to multiply those two, right? And then we'll stick that into our base color. So with that set up, we can save this guy off. And you can see the end result of that mixture. Well, it's looking pretty crazy. And then we can take this guy and we can reapply this a number of different ways. Now, I've had trouble with this in the past, but I'll try it. So I've dragged this off to the side and, oops. Let's pull this guy over. And I should be able to middle mouse button and drop it onto here. Or we can just plug it in. So we've created this material, and now I'm selecting the object itself. And with the object selected, I'm going to navigate to where my material parameters are. And, oh, here we go. Materials, right? And for element 0 of the materials, I'm just going to navigate to my new material, the MBasic one, and it reapplies itself. Aha, yes, I know what's wrong. Okay, so first of all, I'm going to build the lighting. It's still not affecting the... I was thinking maybe the lighting is not affecting this object because there was an error message earlier about UVs, overlapping UVs on this mesh object. So it might not be calculating the light maps accurately. But you can see that our material change has come through. It looks really, really odd. And again, that was my first clue as to the material UVs being kind of all over the place. But you get the idea. So when it comes to creating sort of complex materials, you can build them inside here, right? So let's see. We can do things like, let's say we want to increase the specularity of this component, but we don't want to attach a texture map, right? We can always bring in something like a scalar. Oh. Tab type here, and bring in a scalar parameter, right? And what this does, and we'll plug this into specularity, it allows us to simply assign a value to it, right? So if we come over here, we can set a, max to, let's say 10. Give it a minute to refresh the material, see what we get. Oop. So oh, and default value. Okay. There we go. So we've just cranked up the specularity on the overall object there and applied it to the material. And you can have that controlled by a map as well, right? So we can do that same thing where we bring in this map and say, delete that, and we can take the output of this map and plug it into our specular and have that affect the specular instead, et cetera, right? And that's basically the material editor in a nutshell, right? Now, the reason why I wanted to show you the material editor is that, again, we'll be building a sort of a complex layered material next session, and I'll show you how that works and how to apply that. We'll also kind of extend sort of the sessions on blueprints, and we'll bring in, again, cameras, and we'll add a degree of complexity to it. So this way we'll start kind of building up your knowledge, not just in lighting, but in materials and the material editor and in cameras. And those are the three sort of main areas that I think are important to the stuff that you guys are doing. If there's another area within Unreal that you're interested in, you're welcome to ask me about it. I wasn't going to get into character controls or how to attach a character to certain animation trees and drive a character, because that's sort of detracting a little bit from real-time rendering. But if you want me to touch on that, I can touch on that as well. Okay, so any questions about that at all? No? Okay. All right, cool. So I'm gonna try.
A small question about the megascans thing. Is it
Yep.
limited to just like geography and objects? Can you get any other types of high resolution assets?
Yeah, it's mostly static objects. So from what I've seen, it's just world environment assets and things like that, right? So you won't find characters, you won't find things like that. But if you do that in tandem with the Epic Store, let me bring it up.
Yeah, the free assets.
Yeah.
Right?
Yeah. There's so much stuff. I mean, every month, Epic offers a bunch of assets for free, and I'm always checking in and grabbing those assets. If anything, the value in deconstructing them is immense, right? It's really huge. In addition to that, for those of you guys who want to take sort of your learning further, I'm going to go into new project for a quick sec. If we take a look at the games, right? These templates are really, really good in the fact that they build a concrete foundation in terms of what you want to achieve. Now, I've used the first-person shooter and the third-person template quite a bit, and I've since decided to organize things slightly differently than what they have in those default projects. But they're a great starting point in terms of figuring out how to set up your own games. And it's phenomenal, the templates that you're given. You can pretty much create any kind of game with any of these in here. So they're, again, really fun to explore and deconstruct. And I don't know about you guys, but I prefer learning by deconstructing things that are already there as opposed to watching a YouTube video. I find it immensely more fascinating to pull apart the clock and figure out how all the gears work. Right. So I recommend that for you guys. It's a fantastic way to kind of get into the guts of an engine and figure it out. Okay, so we got like 10 minutes left. I'm caught a little bit on the back foot, guys, because I made the assumption that you guys had Unreal. I don't know why. And I was expecting to give you guys an exercise to do, right? So let's just say have Unreal Engine set up and installed for the next session. And we'll kind of extend on what we have here. So I've got this streaming on Twitch, which is also feeding to my YouTube account. I'm not sure if I gave you my YouTube links. The multi-stream going to YouTube is important because the Twitch stream only holds things for 8 days or something like that. So I'll post in the YouTube account. Let me navigate to it. So you have that as a resource that you can refer to. The other thing is, you guys are now in sync with the indie game development module. So you'll see a lot of the lectures happen twice. And that's just because I had no idea you guys had zero exposure to Unreal Engine. Right? So you guys might be able to actually, I don't know if you guys communicate with the second years at all, but you guys can share notes and ideas and discussions over just learning Unreal. Those guys have been dropped right into the thick of it. Again, I had no idea they had no exposure to Unreal. And so they're getting like bombarded. Okay, so let me grab that link. And I'll post this up for you guys. Okay, so I'm going to post this in the GPU thread. There's a lot of stuff in there too. A lot of other lectures. You're welcome to tap into whatever's up on my channel and check it out. Those of you guys who might be curious about animation or other things can watch. It's all up there, right? Okay, so I guess I'll end off by talking a little bit about some of the costs. Oh, I know. We touched a little bit on things like deferred deferred and forward rendering, right? Last session, I touched on it really briefly, if I recall.
Nothing off the top of my head. I don't remember.
Oh, right. Oh, okay. That's fine. One of the things I'll kind of leave you with, I don't want to get into it right now, but the idea of also starting to think about optimization, right? So one of the cool things about Unreal Engine is that they have profiling tools now built in. Back in the day, we had to do this a very, very difficult way. But Unreal Engine provides quite a few visual tools for you to sort of analyze your scene and see what's working and what's not working, right? So I've got under the viewport menu, under lit, we've got a variety of different modes. We can see lit, unlit, wireframe, etc. Sort of standard stuff for any 3D artist. But down here is where kind of the magic lives in terms of what you can visually see in your scene. So I can turn on things like light complexity, which will show you a map, a heat map. Obviously, the bluer areas are cooler and less calculation intensive. And then the hotter the color gets, the more dangerous it is in terms of lighting calculation, all the way up until red. Red being sort of the worst lighting complexity. There are quite a few different shader complexity is one that we can look at, right? And this one, actually, there's not a lot of complex shaders working here, so we can kind of leave that off at the moment. Quad overdraw. So this is quite handy as well in terms of what triangles are being calculated. And you can see that there's quite a few on the exterior sphere. So that's quite interesting. But you can see mesh density and where the real-time renderer is doing all of its vertex calculations. Quite a few of these different ways of analyzing your scene. Now, there is one other thing that I wanted to turn on here. Let's turn off the quad overdraw for a second. Oh, I thought it was a toggle. Let's go lit. Now, I think it is, where was that? Again, it's up here. Okay, so we can turn on a few things in our display as well that are helpful, right? So one of those I like to toggle as well is the show FPS. So we can see the frames per second as well. So this is a good diagnostic tool for when you're navigating around your scene. Now you'll also see a readout in milliseconds, which is quite valuable. Do you guys know the difference between frames per second and milliseconds per frame in terms of analysis and why milliseconds are a little bit better in terms of analyzing what's happening?
It's just because the number's more precise.
Yes, it's much more precise, right? So the best way I equated it with my game design students is that oftentimes we'll calculate, let's say we render a sequence, that's 120 frames, right? How long it takes that 120 frames is not accurate because let's say we have a camera move that moves from our character entering an arena to a view of the arena, right? So if we calculate, if we say that shot takes 120 seconds, right? Or 120 frames rather, and we calculate the render time, we won't know what is slowing that down, right? Because that camera move starting on the character might be going lightning quick, and then the minute it rotates around to look at the arena, it might slow right down. So it doesn't give you an accurate measure. So when we're offline rendering, we calculate how many minutes per frame, right? So it's the same thing here, except in milliseconds, right? So you want to see what individual frames are costing you, not the overall frames per second, right? So it is all about accuracy, right? That way, when I'm looking around here, I might have a different millisecond read when I look this way than when I look that way, right? And then you can go, oh, it's because I got more objects here that my milliseconds are slowing down. Whereas with frames per second, you're just getting frames per second as the camera moves around, and it's not as accurate, right? So there are a few other sort of HUD displays that can come in handy here as well. Under the stats menu, we can also bring up, well, quite a few different things. Let's see, what would be a good, let's go into the engine actually, and let's bring up a detailed list, right? So we can see, this is quite cool. I love this because we can see the millisecond budget as an active graph as we're moving around the scene, right? And we've got a few other displays in terms of millisecond per draw. And we've got the overall game in terms of millisecond. And then, you know, how long it takes the GPU to process what is being seen through the camera view, the memory being taken up, and the V memory being taken up, and all that kind of stuff, right? So that's really kind of handy when you're looking back and trying to optimize your game. Having those diagnostic tools mean that you can travel around, take a look at certain areas, and really kind of understand what's killing your frame rate, and that's sort of the big thing. So I find stuff like that really, really cool, right? Just because it's super helpful in terms of just trying to figure out how to get your game running faster, smoother, et cetera, et cetera. Did I turn that? Yeah. Oh, that's bizarre, guys. I turned on the detailed readout and it turned on, and I'm trying to toggle it off and it's not toggling off. There you go. Okay. So there we go. Just some visual diagnostics that you can run. I'm going to talk a little bit at length about the output log, which is effectively your console, which you can access like any console you would in a game by the tilde key, right? So when you hit the tilde key, it'll bring up the output log, which you can also bring up in here somewhere. So you can bring up the output log manually, but I'm used to the tilde key, and it'll pop open the output log, and you'll have access to a variety of different commands. So for example, if I type in stat FPS, this should toggle my stats off, and then I can bring it back up, stat FPS, and then we get our FPS back on, right? And you can see that the things that I've turned on here, so we can do, let's see if the stat will turn it off from stat detailed. I don't know how to get rid of it now. Maybe maybe I need a flag. Oh no. Oh, there you go. So that's kind of what I wanted to kind of cap it off with. We talked about sort of the basic framework of world lighting. We talked a little bit about how a blueprint works, and I showed you the basics of how to connect up a material and apply it to the object. And we looked at a couple of visual diagnostic tools, which I'll sort of extend, and we'll talk a little bit more about optimization considerations going forward as well. Okay, so any questions about that at all? No?
No question specifically for
Okay.
this, but I just wanted to ask just
Yeah.
generally, as soon as you hear word of what kind of content the exam is going to be covering, I'd like to start making like open book notes as soon as possible.
Sure, yeah.
So
Yeah.
once you have an idea of what the content would be, like example topics, that is,
Yeah.
I'd like to get started on making notes as soon
Yeah, yeah, for sure.
That'd be
Yep.
fantastic.
Yeah, for sure. So my plan after I hang out with you guys is to sort of, well, I got a meeting, a student one-on-one meeting, but later on this afternoon, I'm going to do a catch-up email to Gordon today. And then we'll get some more details about the exam for you guys, as well as making sort of a second class arrangement with Dave and John for you guys. So you get sort of additional lectures on OpenGL. Okay, so I will let you guys know later this afternoon what the status is, so you guys can plan around
Right.
it. Yeah. Okay.
Yeah, that pretty much covers everything for this module. Although I
Yeah.
just have like an off-topic question.
Sure.
Generally.
Sure, hit me.
So this is with regards to emergent trends. I mentioned how last time, if it's possible, could we, because we have these fortnightly meetings with you, right? You're
Yes.
okay to keep meeting on that basis. So
Yeah.
the time slot we meet, I was wondering if 12 to 1 or 2:30 to 3, 12 to 1 on a Monday, or 2:30 to 3:30 on a Friday. Do either of those time slots work for you?
2:30 to 3:30 on Friday. Yes, actually, I can do that. My commitment on Friday is freed up, so I can do sort of the emerging trends then. So Yeah, I got you in there. I like talking to you guys. You guys got a good project going on, so it's all good.
Yeah,
Yeah.
I'd like to have these long chats with you about the project too.
Yep, for sure, for sure.
Because, well, I was hoping we could reschedule it for a different day because on Thursdays we only get that half hour. You know.
Yeah.
It's not enough.
Yeah, no worries. No worries. I got lots to talk about. I'll talk your ear off. But but something to note, you got this is specifically to the group that I supervise. But Ellie and Gareth, just so you know, they're not only the top students in the university, they're the top students I have encountered in a decade of teaching. Right? You've got really two of the most talented artists that I've had the pleasure of teaching in decades. So use them. They will bring your project to life in ways you can't even imagine. Ellie on her own is a phenomenal concept artist, and Gareth is a 3D modeler above industry standard. So just something for you guys to keep in mind. You guys have a really, really good team. A lot of talent on your team. So there we go. That's enough of me bigging up my other students.
That's all good.
Okay, cool. It's been a pleasure, and hopefully you got a lot out of today's session. I feel like even though I was lecturing, it felt a bit rudimentary for you guys, but don't worry. I'll start to layer in complexity. This was just a general overview. Now, as with everything that I tell to my other classes, I'm a constant user of the software, so sometimes I'm clicking on things and not talking about what I'm doing. You have to stop me. You know how it's like when you use a piece of software and you know where everything is? You'll just bam, go and find stuff. And other people watching going, whoa, wait, Al, back up. What did you just do there? So you guys got to stop me. I'm notorious for steamrolling through software, right? So, and in that regard, if there's something that you try on your own and you get stuck, just pop it in Discord, right? I'll jump up and say, oh, hey, no problem. This is where you find that, or here's how you click on this, right?
Yeah, no, if we're going to be working along with our own solutions next week,
yeah,
I'll interject if I happen to fall behind.
No worries. It's fairly straightforward. I think the degrees of complexity is nothing compared to what you guys are dealing with inside an IDE, but it'll be different because you'll be dealing with a lot of the concepts, but primarily visually, right? So I'm hoping it complements the kind of stuff that you guys are doing so that you can see, this is the final sort of material implementation and what I'm doing with, my physically based rendering shader, and this is how it's going to be implemented by an art team and what it's going to look like. The Unreal Engine has a hardware, has a rendering abstraction layer, which I'll talk about. So you're not dealing directly with OpenGL or DirectX. You're dealing with something called RHI, which is their, I think it just stands for Rendering Hardware Interface. And it's just a scripting language overlay in terms of accessing OpenGL or DirectX. But we'll talk a bit more about that next class. Okay, cool. That being said, I will let you guys go, and I will talk to you later.
All right, thanks.
Yeah, cheers, guys. See ya. All right, so for my Twitch stream, oh my God. Okay, so how did I turn this? Let's figure out how to turn this off. My God, man. All right, it never fails. When I give a lecture, there's always something. Is it the raw data? They give me raw data? What is the raw data? And I turn it off and nothing disappears. Unit graph, max. Let's turn these all off. Let's hide all, right? And let's bring these back one at a time. Hey! Hey, Bartos, how's it going? Yeah, I was just waiting for everybody else to log off.
Yeah.
Let me stop my Twitch stream.